Hello, math students. Welcome back to our module on statistics. This is lesson 4, and it is called Variability in a Data Distribution. All right, our goal for today. Today we will learn how data must be judged by its variability as well as its mean. The question that I want you to think about during this lesson is, when your mean values are the same, how do you know which one has a better indicator? Okay, so basically what we're trying to figure out is is the data that we found and the mean that we found a true picture or indicator of our data set. And so we figure this out by doing a couple of steps. What does the data show? So we have some soccer games, okay? And in the soccer games, we kept record of the goals that were scored. So our data is actually goals, boys' goals and girls' goals. And we have to compare that data to figure out what would have the better variability. So the way that we do that is we take the data that we have and then we look at it to determine what we can see about the data itself. So the first way to figure this kind of stuff out is we have to draw a dot plot for each set of data. And when we're talking about each set of data, this right here, the boys' goals, is a set of data, and the girls' goals is a set of data. So we need to draw two dot plots, one for the boys' goals and one for the girls' goals. And then we're going to figure out what to do next. So the first step, it says, is to draw a dot plot for each set of data. So here I have a number line. Remember, it's the x-axis. And I am doing a dot plot, and it says 0 being the smallest, 7 being the largest, so I'm going to say 0 is here. 1, 2, 3, 4, 5, 6, 7, and I'm going to go ahead and put 8 just because I have room. And then I'm going to plot it. So I had 1, 0, 1, 5, 1, 3, 1, 7, another 0, and another 3. Okay, so that is, let me label it, this is the boys' goals. Okay, and now let's do another one, and this time we're going to do it for the girls' goals. Okay, the lowest over here is a 2, the highest is a 5, so we'll go ahead and label it the same way. 0, 1, 2, 3, 4, 5, 6, and I'm out of room, so we'll go ahead and stop there. So I have a 2, a 3, a 5, another 2, another 3, and another 3. Okay, so according to this, it says draw a dot plot for each set of data. Oh, I forgot to label it. Don't forget to label it. That's so important. Girls' goals, label it so we know what we're looking at. All right, now it says determine the mean for each set of data. Okay, so we're supposed to figure out the mean. And remember how we did that, fair share, which that takes a long time. So what did we talk about doing instead of doing fair share? We said that we could take each data set and add it all up and then divide it by the total data sets. So we have a 0, a 0, a 3, a 3, a 5, and a 7. I'm supposed to add all those together. So 0 plus 0 is 0, 3 plus 3 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I got 18 here. And then there are 1, 2, 3, 4, 5, 6. So I take 18 and I divide it by 6. 6 goes into 18 3 times. So now I have found that my mean is 3. All right, I got that. So that part is done. Yeah. So now I'm going to do the other side. So let's go over to this one and do the same thing. So I have 2 2s, 3 3s, and a 5, and I'm going to add them all together. So 2 plus 2 is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18 again. 1, 2, 3, 4, 5, 6. So I do 18 divided by 6. 6 goes into 18 3 times. So I found the mean for the girls' goals is also 3. Okay, so it said determine the mean for each set of data. Now it says which data set has the higher variability. Well, what we're going to do is we're going to extend our mean up so we can see it because I ran out of room down here. And what I want to do is, since this is the mean, I want to see what my distances would be. So from here to here is 3 hops, right? From here to here is 3 hops. From 3 to 3 is 0, right? And from 3 to 3 is 0. From here to here is 1, 2 hops. And from here to here is 1, 2, 3, 4 hops. So that's what we have to check. 3 plus 3 is 6. 2 plus 4 is 6. So it's balanced like it's supposed to be, but it says which data set has a better variability. Variability means how much it varies. Does it vary a lot? Are they spread out? Or does it vary a little tiny bit and they're all clumped together? So I'm also going to try to determine what my balance would be on this side to make sure that we're good. So from here to here is 1 hop. From here to here is 1 hop. From here to here is a 0, 0, and 0. And from here to here is 2 hops. So check and see if you're balanced. 1 plus 1 plus 0 plus 0 plus 0 is 2. And we have 2 on this side, so we are balanced. But again, variability. You have low variability if all of your dots are clumped close together. You have high variability if your dots are spread out. Did you hear what I just said? So what you have to do to determine the variability of a data set is you have to look at how your dots on your dot plot are clumped. If they're clumped close together, then you have low variability. If they're spread out, then you have high variability because it means that they vary from each other a lot. So look at this. We went all the way over to here, all the way over to here, stayed clumped on top of each other here, and pretty far over here and pretty far over here. So those, to me, if you're looking just at the dot plot, those dots are spread out pretty far. Now let's look at this one. They only went 1 to get here, 1 to here, clumped on top of each other here, and only 2 here. So these, in the girls' goals, looks like it's clumped closer together. So for me, what I would determine as the statistician, or the mathematics person studying statistics, I would say that you have a higher variability in the boys' goals than in the girls' goals. And the reason why it's a higher variability is the boys' goals are spread out, whereas the girls' goals are all clumped together. Okay, so when you're talking about variability, it is based on what the dots look like in their clumping. These guys are spread out, high variability. These are clumped together, low variability. Okay, so which data set has the better variability? I would say the boys, because it's higher. They're spread out. The girls is lower, so it's less variability. Okay, do you understand variability now? I hope you do. So going back to our goal, today we will learn how data must be judged by its variability as well as its mean. So looking at your dot plots are really helpful when you're trying to determine what variability is. Variability is determined by how far they are spread out. Okay, these guys are spread out far, these are clumped together. Better variability than these. Okay, all right. Question, when your mean values are the same, how do you know which one has a better indicator? It would definitely be based on the other data points and how far they are away, because we have these 2 that are the same, and we have these 3 the same. However, we have 2 that are 1 away, 1 that is 2 away, 2 that are 3 away, 1 that's 4 away, and 1 that's 2 away. So this one does have higher variability. Okay? All right, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye.